All right. Caffeine-free nomenclature. How do I start this molecule? What should I draw first? Sorry? I think he confused this with undecane. Yeah, this one's not the undecane. This is the icosane. I see that mixed up. I see it. But this one's the 20, icosane. So it's one of the 5 of the weird ones. Remember the first 4 make no sense? First there was me, and then I met Ethel, and then we produced a baby. That doesn't work for anybody except for me because I had an Aunt Ethel. You guys prefer me peanut butter. Me, methyl ethyl or methane ethane, peanut butter. Propyl butyl or propane butane, right? Me peanut butter. Just totally nonsense. For me, it's got sounds in it. I'm going to remember something. Okay. So icosane, you're going to do 20 in a row. All right. I didn't even skip it yet, did I? Yeah, I think I did. There we go. 20 in a row. And we got 2 copies. This one I'm going to stretch down a little bit. 20 in a row. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Verify. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 20. This one's cyclopropane. That's not a big one, is it? Cyclo means what again? Ring, and this one's only 3 carbons, right? Pro. Now, if you're doing the pro-pent mix-up, which is one of the most common mistakes I see, I make it occasionally because it's just especially I'm a sound guy, right? They start with a P. So you should always think about pent first. Don't ever think about prop by itself. There's where you can get them backwards. But if you got pent in your brain, you know that one means 5, right? Pentagon, 5-sided figures. So prop must be the other one, which is the 3. Cyclopropane is just a triangle. And some of you have read about why this triangle is very unhappy. And when I say unhappy, I mean unstable, right? Heptadecane. Oh, this is one where you shouldn't draw 17 in a row. This is the one. Can I use the young lady's name in the second row who asked the question last video? Can I use your last name? Yeah. Or it's going to be on video. Yes, Miss Patel asked last time. Now I'm forgetting what she asked. What'd you ask? Oh, when there's multiple rings. Yes, yes. And this is one where there is multiple rings because it's got bicyclo in front. So in this one, don't start by drawing anything except for these 2 things. It's a whole new ball game, by the way. You see bicyclo in the name? As its name implies, multiple rings, right? What you need to do is just draw 2 carbons and draw them in the form of dots. Just dots. Carbon 1, carbon 2. And you want me to show you how to connect to the dots? Because in the name, it tells you you need 6 more carbons between the dots in one direction. You need 5 more carbons between the dots in another direction. And you need 4 more carbons between the dots in a third direction. So do that. It's 6 extra carbons. Please don't count the dots. And there's a reminder here to not count the dots. Right beside the 6 is one of the dots. That's what you should treat it as. That dot is not an accident. It's actually, you already drew it. It's one of the dots. And you know the main rule of nomenclature? No carbon ever gets counted twice. Every carbon gets counted exactly once. And you're either part of a chain or ring, which is the end of your name, or you're part of a group, which goes in the front of your name. Right? Got it. So this name is not going to have 15 carbons, the total. It's going to have 15 plus the 2 dots is 17. Okay, 6 between the dots. I don't care if you go up or down or in the middle. 1, 2, 3, 4, 5, 6. I know it don't look pretty, but it's got 6 new carbons, doesn't it? 1, 2, 3, 4, 5, 6. You don't like that? Because you don't know, like if you're like me and you didn't know how to make the pattern end pretty, Here's an alternate that students typically really like. You do your 2 dots. This alternate is going to get full credit. And you see it's a bicyclo. You just do this no matter what. There. Now put 6 new dots on this. Space them pretty evenly, okay? This is so you don't have to purposefully try to draw the right shape. There's 4, there's 5, there's 6. That's got the information I need, people. This is another way to do it. You want to draw every ring ever as a circle with dots in it? Feel free. You want to start over here? Feel free. You could have started here too, right? That's cyclopropane up there, isn't it? Using my same rules. Cyclopropane. What else? 5 more between the dots. You pick a direction, middle or down. I'm gonna go in the middle. 1, 2, 3, 4, 5. Worked out a little better this time. This one I'll go down with new dots. 1, 2, 3, 4, 5. And then I need 4 new dots. So on this one, I'll go 1, 2, 3, 4. And this one, I'll go in the middle with 4. 1, 2, 3, 4. So all the chains are done, or the rings, or the bicyclic ring. Okay. Going to take it upstairs, put some groups on the first one. Parentheses is a new thing too. I'm throwing in a lot of new stuff here, aren't I? Some of you have read this already, so it's not new stuff. On carbon 6 of icosane, that's what this means. 6 is the carbon of icosane. 2, 4, 6, right there is a group. The group's name is in parentheses. The reason it has to be in parentheses is there's a group on the group. So the number in the parenthesis has nothing to do with icosane. It says on an ethyl group, you put an iodine on carbon number 2 of the group. You already know carbon 1 of the group is the one attached to the chain. You might not know that. Like I hinted at it previously in today's lecture, but I'm telling you as a fact. In a group, carbon number 1 of the group is the one attached to the chain. Down here, if I have the same thing here. Carbon number 1 of propyl is the one attached to cyclopropane. It's not a chain, but it's a ring. So here is my first carbon of an ethyl. How many carbons in an ethyl? How many more carbons do I need? That was 2 different questions, sorry. I have 1, I need 1 more, right? So I draw my 1 more. What carbon number is the one on the end? 2, that was number 1. I'm gonna try to make it just look a little neater, that's all. And that didn't end up in green. How about a straight line? There. And which of those gets the fluoro? This first one or this second one? I think you know the answer. Second one. So there's your iodoethyl group on carbon number 6. Let's put that in a different color than blue. On carbon number 8, what should I draw? What's the group sticking off of 8? Is it a trimethyl group or a pentyl group sticking off of 8? And yes, I sometimes halogens get mixed up a lot with me. You know. Here's a transmutation. Transmutation, you ever heard of that? They were trying to do it for thousands of years, trying to change things like lead into gold. I just did it right now. I changed the fluorine to an iodine. Yeah, it's an iodoethyl. Where fluoro came from, I have no idea. Oh, because I was obviously looking ahead at the next example. Welcome to my brain. Carbon number 1. Oh, this question is a, what do you call it? A unicorn. Which one's carbon number 4? You got to edit your question. The instructor clearly had another molecule in mind. I don't want them on the same carbon. So it's got to be 1 and 2, right? Please fix your question. It was wrong. Sorry? Oh, I haven't even finished the first question. Yeah, I started and then I looked at the next one. Yeah. Thank you. Let's go back to that first one. So what do I draw off carbon 8 on the first molecule? And the question was, do I draw a trimethyl or a pentyl? And you said draw the pentyl because that's the part attached. And carbon number 1 is the first carbon you draw. My pen is migrating. Here we go. And 1, 2, 3, 4, 5. And then on carbon 2 and 3 and 4. So a reminder, carbon 1 was here. Carbon 2 needs a methyl. Carbon 3 needs a methyl. Carbon 4 needs a methyl. That's done. 1, 2, 3, 4, 5 with methyls on 2, 3, 4. And the molecule is done. On carbon 1 of cyclopropane, I'm going to draw a 3,3,3 trifluoropropyl. So what do I draw first, the trifluoro or the propyl? The propyl. How many in a propyl? Is it 3 or 5? 3. Somebody fell into the trap. That person, they're out there, all of you. I'm one of you. The person that said 5, next time you always got to say pence 5, pence 5, pence 5. No matter whether it's propyl or pentyl, just to yourself, pence 5, pence 5. Because then you won't call prop 5, right? And then propyl, 1, 2, 3. And then which carbon gets all the fluoros? Third. I'm going to show you 2 ways to do it. One way is this way, CF3. That's one way. Another way is to do it like this, 1, 2, 3. Error is to do it this way, error. I see it every semester. That's why I'm bringing it up. Somebody's going to do this. They draw their propyl because they were told they're following that step properly. And then they do this. Tell me 2 things they did wrong. You killed a carbon. You're now down to ethyl. And a bond to F3 would be this. Off of the end, this equals this, CH2C, and then F, 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 with 2 pluses, and it's wrong because it has charges, and it's a unicorn. What does that mean? What does unicorn mean? When I write unicorn, it always is the same meaning. Doesn't exist. You'd like to believe it exists because unicorns are wonderful, but they don't. Okay? So it's just wrong on all levels. I have to make that very clear. There. And on this one, same story. I'll draw the other one. If you need to draw it like that and you want to draw F3, you better say, yeah, this is a C, and there's 3 F's on it. That's what you were trying to draw when you made that mistake. And on carbon 2, we have to draw a triiodomethyl. How come there's no parentheses? It's got a group on a group, but this time there's no parentheses. It's a methyl, isn't it? Do you have to tell me where on the methyl the fluoros are attached? Because that's the only thing the parentheses are for, to tell me where in your group things are attached. There's only one place to put groups on a methyl, it's the methyl. So you're going to put on carbon 2, CF3, or on carbon 2, you can go like this. And I know I haven't covered the CIS prefix yet, have I? I always do it after the fact. I draw it like there's nothing cis or trans, and then I realize cis means they're both either sticking out of the ring towards you, or they're behind the ring sticking towards me. You show me one or the other. And what's our short form when drawing bonds? To show bonds coming out at you? How do I draw those? A wedge, W-E-D-G-E. So you can make them both wedge, and I'm doing it after the fact. Those are both wedges. Is a I? Yeah, I did it again, didn't I? Welcome to my world. Time for more transmutation, right? I wrote trifluoromethyl instead of triiodomethyl. I just don't know. It's I, right? No transmutation. Just fix it, Dr. Wigman. I3. Yeah. And on this one, I'm going to go dash, dash. So dashes are like zippers, okay? Just retrofit it. Make it a zipper. Please make sure your zipper goes all the way. Another error here. Going to get another pink thing through it. I'll see this a lot. They'll draw the ring. They'll do their zipper. But they'll forget. They'll stop it halfway. They'll do this and that. Oh, my computer does that all the time. Where was I? I was here, right? They're doing this. Oh, my bad. They do it here. They only colored in half of the thing with a dash. This is now a 3. That's 3. 2, 2, 2. Triiodo ethyl. Do you agree? The end of the dash is a new carbon you put in there by mistake. And then the remainder is a bond. You can't have a bond start as a dash and end as a not a dash. Okay, that would be a bend, wouldn't it? A bend is called a carbon atom. So that's not the group you were asked for, so I'm going to put a big X through it. Trying to catch mistakes before they happen. Okay, we fixed everything. Trans 1 neopentylate sec octyl biso. Wow. I'm going to spend a couple seconds on bicyclo rules. You read about them, right? They're new. They got those 2 dots, the green dots, the original green dots. They have a name. They're called the bridge heads. They're the only 2 carbons in these molecules that every ring shares. That makes them unique. This is only part of that ring and the bigger ring, but not part of the smaller ring down here. You see what I'm saying? This one's part of any ring you draw. So is this one. They're called bridgeheads. One of the bridgeheads must be carbon number 1. That's a new rule. Okay? You decide when you have to draw them. It's up to you. On the first one, I'll go 1 over here. On the second one, I'll go 1 over here. And what's that group on carbon 1? It's a unique group. It's not like sex or isos or terts where there's thousands of them. Okay? There's only one neopentyl, so it's got 5. There's no neohexyl, there's no neooctyl, none, no. And I just call it the broken chicken foot. You start out with a bend and then you draw the chicken foot. Don't get it backwards. Don't draw the chicken foot and then a bend. That's just a tert pentyl. So you draw a CH2 on carbon 1, and then a chicken foot. So how many carbons are in that green thing? Don't count carbon number 1 of the chain. There's 5 carbons starting here, right? 1, 2, 3, 4, 5. And it's CH2 with a tert butyl off it. Chicken foot. 8. What's our strategy for doing a sec group? Green was a bad choice because my dots aren't sticking out anymore. There they are. I'm going to draw 7 in a row. 2, 3, 4, 5, 6, 7. Where's the 8th go? I need 8 in an octal group. Where's the 8th carbon go? Off the first one you attach to the chain. There you go. And you might, most of you probably know that if cis has them both on the same side of the ring, like these 2 examples here for cis, trans has 1 sticking out, wedge, and 1 coming back, dash. So on my first one, I'll have the wedge on the neopentyl, and a dash on the other one. Make sure it goes all the way. And then on this one, I'll draw dash to the neopentyl and wedge to the sec octal. Make sure that's 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Good. Both of those are getting full credit. Please don't do 2 examples on any questions. Just pick one or the other. We learned a lot. I'm going to kill the video and you guys can make sure you got it down.